A very good morning to all of you. So today we are here to understand the implementation of a stable multivibrator using every circuit software. So basically this IC is used for the implementation, and this IC 555 can be operated in three different modes. The first one is the monostable mode, then second one is the bistable mode. It means both the states are permanent, or you can say both the states are stable, that is plus 5 volt or 0 volt. And in the astable mode, none of the state is stable. So the simple circuit is there, and this IC 555 is an 8-pin IC. You can see that the power supply is connected to 4th pin and the 8th pin, and the output is taken from the pin number 3. Now there is an RC circuit, and this RC circuit will be used for the generation of the square wave pulse. The 2 and 6 pin are shorted. So I think we can connect, or you can have the implementation in the every circuit software. So now going back to our software. So first I'll remove this thing. Just a minute, I'll remove. Okay. Now first we'll take the IC 555. So there's a library. From here you can take IC 555. Okay, so you can see here this is an 8-pin IC. Now to this we will have to connect VCC. VCC of 5 volt is required. So for that you will have to connect a DC voltage. You are having an AC voltage also. So basically this is a 1 volt source. So what we have seen that you will have to connect this one, then right, the 4th and 8th pin are connected, but here you will have to vary the voltage. From this you can see the default value is 1 volt. So suppose if you want to vary this thing, then you will have to highlight this component, and then you will have to select this tool. So for varying the value of the component, or you can say any library component, so in that case you will have to click this. So after clicking, a small dial will get open in front of you. So now you just have to vary the voltage. So I think 5 volt is required. So this is a course adjustment. So I think for if you click here, then you can have the fine tuning of your value. So now we will be requiring 5 volt. So here this will be connected. Anyways, you will have to connect a power supply with respect to ground only. So now next is what you should have the RC combination circuit. So for that we'll be taking the help of resistor. So I think resistor is connected, then again you require one more resistor, so that is also connected. Then you require a capacitor. This is the unpolarized capacitor, and this one is the polarized capacitor. So this is the thing. Okay, just a minute. Now again you will have to connect these ground. Okay, that is okay. Then 2 and 6 pin are shorted, or 2 and pin, just a minute, I'll, okay, no issues. Now the 7th pin is connected between the two resistor, that is RA and RB. So you can see the connect, how I'm making the connection. You just have to click here the first end and the second end. So you can see the connection has been made. Now okay, now the 6th pin and this one, this is also connected. So basically just a minute. Okay, so this 4th and 8th pin will be connected to the first end of the resistor. So this is connected, this one is okay. Now this is the output pin, and between 1 and 5 you will have to connect a small value of the capacitor, and that is used to remove the noise signal from the circuit. So okay, just a minute, it is 0.01 microfarad. Okay, this one is grounded, this one is grounded, so I'm connecting a ground to pin number 1, then capacitor. Now you will have to reverse this. Now how you are going to reverse? So when you highlight this component, you get some tools, and this one is used for the reversal. If you want in the anti-clockwise, or if you want in the clockwise direction, you can have that thing. So this one is okay. Now place it here. After placing, okay, just make a connection between this. So now you will have to change the value, and you will have to measure the voltage. So for measuring the voltage, you need the measuring instrument. So voltmeter is the measuring instrument. So this one is right. Then you are having this ground. Okay, now the values. So we'll see the check the values. I think it is 10K for RA, 5.6K for RB, 0.1 microfarad for this capacitor, and 0.01 to remove the noise signal. Okay, so we'll do that change. So again, if you want to vary any value, so first highlight this and click on this tool. So I think it is 10 kilo ohm. Okay, it is 10 kilo ohm. Okay, just a minute. Right. Then 1K, I think it is 5.6K. So 5.6K. Just a minute. 5.6K. This is 5.6K. Okay. So this one is 0.1 microfarad. So I think it is 0.1 microfarad. So that is 1000 nanofarad. That is 1000 nanofarad, or I think it is 100 nanofarad. 100 nanofarad will be the value. 100 nanofarad. Okay, just a minute. That is okay. Now this one is 10 nanofarad, because you are requiring 0.01 microfarad. So that will be 10 nanofarad. Okay, just a minute. 10 nanofarad. Right. 10 nanofarad. Okay. So just make the connection. Okay, the connection has been done from our side. So now you will have to run the simulation. So for running the simulation in a transient state, so you will be having this tool, that is T. So click on here. You can, now you can see, you can have the square wave. Then this is the capacitor voltage, because the capacitor is getting charged and then it is discharged. But I don't think we require some DSO like waveform. So for that, just a minute, I will have to check this. No, this is not a, this is for a screenshot. Then this is the simulation speed. Okay, just a minute, I will have to check. For that, you will have to click this pin. Okay, if you want to see the DSO type waveform, no, so in that case you will have to click this one. So now you can see, you can see the square waveform is there. Now if you want to check the capacitor voltage, again you will, the capacitor voltage is measured at the point number 2 and point number 6. So we can say this is the capacitor voltage. Just a minute. Yeah, so I think this is not a capacitor voltage. You just have to click here only. Yeah, now it is okay. This is uh, just a minute. I think the capacitor voltage, this is this I am showing the capacitor is charging and discharging. Wait a minute. Wait a minute. Okay. Yeah, now it is okay. You can see the capacitor is charging. When the capacitor is charging, you are getting high pulse, and when it is discharged, you are getting a low pulse. So in this way, you can implement the astable multivibrator using IC555. This is for today. We'll meet in the next class for the new implementation. Thanks a lot.